and Head of Computer Engineering Department at Don Bosco College of Engineering, Goa, India. He has a bachelor's and master's degree in computers. He also had a PhD from Vellore Institute of Technology, Tamil Nadu. He has over 16 plus years of teaching experience. He is currently pursuing his postdoctoral research in Malaysia. He has one patent to his credit and has several notable research publications. His research area includes image processing, physiologic, and rough set theory. He received grants from DRDO India and MPOB Malaysia. He has conferred with several awards, a few notable ones being the Aropath Global Award 2019 for Excellence in Research by Sri Aurobindo Society, Chhattisgarh, and the Best Faculty in Funded Research Award by CSI India Mumbai Chapter. He was awarded a gold medal and won the Asia Innovation Creativity Award at World Invention and Innovation Contest, Seoul, South Korea. It is our great privilege, sir, to have such an eminent personality as a resource person in this faculty development program, sir. So now I request you to enlighten us by sharing knowledge on grading of oil palm fruit using artificial intelligence. So now the platform is yours, sir.
Yes, sir. I hope you can see the screen.
Yes, sir. We are able to.
Okay. So it's already 4:02 p.m. and I think it's very high time, tea time you can say. So you can start your tea and listen to the presentation, because for the students also it is very difficult to concentrate starting from 9 a.m. till 5 p.m. I can totally understand. We are also faculty member, and I'm very lucky that today I'm interacting with all the teachers. I'm also a teacher. Happy Teachers Day to everyone. You are doing a fantastic job. We as a teacher, we are in very noble profession. We teach students, and these are the future of India. So my wishes to all the lovely teachers present over here. My name is Gaurang. I'm working in Don Bosco. Sir has already introduced me. So let me tell you, recently I received one more gold medal from international competition for my postdoc work. And also I received a special award from Macau Invention and Innovation Society. So this is happened just last week. And last week I was just interacting with, we had 1 week program in funded by government of Goa, and I was interacting with Chief Minister. And we were thinking what we are doing in research, what we are doing in students community to have this enterprising mindset, which will lead us towards center of excellence. So what I'm trying to do is, I'm trying to share my research, which I have done for the society as a part of my research, and I received grants for this from Malaysian Palm Oil Board. So this is today's outline. I will just introduce you the topic, then the definition. What are the objectives of this research? Then I've divided this research into 5 different chapters. Don't worry, I will not go into detail, but what I want to convey from this presentation, I will tell you in my own words.
Excuse me, sir. My request to organizers, can you please permit the guests to messages, sir, because messages is given only for the members, group members, team members. As we are not the members, we are the guests. Can you please permit the guests to post the messages, please? I'm sorry for disturbing you. Thank you, sir.
Yes, otherwise you can post that message in our WhatsApp group, sir, so that our coordinator will ask the question.
Okay. Thank you, sir.
Thank you, sir.
So this is the research outline. Today's presentation outline. I will introduce you to the research topic. In the previous session, sir has already introduced you what is AI, why it is used, where it is used, what are the different phases of AI. When we talk about artificial intelligence, we all know that it's an umbrella where we talk about data analytics, we talk about machine learning, we talk about natural language processing, we talk about fuzzy logic, we talk about expert system and neural networks and so on. So you know already about artificial intelligence. Having that artificial intelligence knowledge in the background, what I have done is I have taken one common problem. Now, getting research problem is, or framing research problem is very, very important. And how you can do it? You have to attend few lectures, seminars, guest lectures, and workshops. So same thing I did. So when I went to ICAR, that is Center for Artificial Intelligence, Center for Agricultural Research, Goa, I interacted with scientists, and then they said, yes, they have a problem which the computer engineering person can solve, and it's a major problem. He gave me, there are three problem definitions. First one is related to coconut, second one is related to oil palm fruits, and third one related to amaranthus tricolor. Amaranthus tricolor is, for your kind information, it's a red color vegetable. So we can explore more things in this area also. Then what I did is, we know that as a teacher, what we do is we check, we collect the requirements, then we do analysis, and we check whether it is feasible to do this type of research or no. For that, what is important for us is we know that we do literature survey. So I downloaded a lot of papers related to oil palm fruits and its related research related to computer. Most of the papers I found are from Malaysia. Okay. And as we know that India is the largest importer of oil, palm oil, and few years before the largest exporter country was Malaysia, and now it is Indonesia. The production is very good in Indonesia. At the same time, why you have to understand why the production is very good in Malaysia and Indonesia. It's only because of the humid climate and water supply. So same type of climate we are facing in the coastal area. You know that in Andhra we have the same type of climate. We have in Tamil Nadu, we have mostly humid climate, and there are some districts where you have a lot of water supply. Similarly, West Coast also in Goa, we have similar type of climate. Okay? And there are some talukas where oil palm fruit plantation is there. So what I did is to solve the problem. To solve the problem, we have to actually go in the field and find out whether there is a problem and what type of problem farmers are facing. So I went to 4 to 5 big plantation of oil palm fruits. And there I noticed that, along with the scientist, of course, and there I noticed that when the trees are very high, it is very difficult. It is impossible, you can see, to climb those trees. On the coconut tree, it is very easy to climb because we have Teddy Pepper who climbs on the tree and then removes the coconut when they are ready to harvest. But that is not the case with oil palm fruit. There are thorns, okay, and you cannot climb the trees. So what farmers do? They make use of big sickle or chisel to cut the bunch from the tree. And standing down, you cannot actually see whether the fruit is ripe or no. And if there is a mistake, okay, and if you cut unripe fruit, then that full bunch is, the oil extracted from those bunch is of no use. So then they make use of those that oil which is extracted from unripe fruit. They mix that oil in tar or some chemical industries, which is not of good quality. So after initial investigation and interaction with the farmers, we came to know that automated grading of oil palm fruits will have a major role in the future of oil palm industry. You know that in Andhra also we have one oil palm industry. Then in Goa also, Godrej Agrovit Private Limited, they are extracting oil from ripe fruits of palm oil. So that was our research problem definition. So research problem definition was already formulated. Now we have to understand the system. before implementing the system, it was my duty to check whether I understand the whole system. And once you know the whole system, then it is very easy to design and then go for implementation. So one point which I want to mention here is when I am talking about automated fruit grading, you know that appearance of the fruit is very, very important. When I say appearance of the fruit, it can be a shape, it can be a color, or what is the size of that fruit. We have to consider this to check the grading of fruits. And in my case, color provides very helpful information in estimating the maturity and examining the freshness of fruits. So as I already mentioned, that's the reason there was one competition in Malaysia, Selangor, organized by Ministry of Plantation and Commodity Industries, Malaysian Palm Oil Board. So I participated for it, giving the same research problem definition and the solution proposed. For the first round, I got selected. Then they called me for the second round. So I went for the second round. There was rigorous discussion, brainstorming, how you can do it, how you can achieve it, and blah, blah, blah. I cleared that, and I was not hoping that I will go for the finale and I will get research grants from them. But luckily, I was the only one from India, and I got research grants of around 20,000 ringgits from Malaysian Palm Oil Board. That was like a big achievement when I was in Vellore Institute of Technology. So of course, my guide was from Andhra. His name is Dr. Anjanelu. I am thankful to him. Because of him, I got to know that there is such type of competition, and I got a chance to participate in it. So that time, that news came in the VIT's newsletter, and then it was very good thing for the VIT. So what I'm telling you is out-of-box thinking is very important. And research, what we are trying to do, it should be helpful for the society in solving their basic problem. Otherwise, what we do is we do research, we publish papers, and then those papers are kept in the book or in the form of journals. But if you do something which will be helpful for the society, publish those papers, then of course I feel personally that I have done something for the society. So that's a satisfaction when you get it's really amazing thing. So after interacting with farmers, what I understood is currently there are 4 different varieties or categories of fruits. First one is ripe. Of course, we know what is ripe. Then after ripening the stage, last stage is overripe. You have to remember one thing, overripe fruits cannot be used for extracting oil. They are of no use because the free fatty acid contents which is present in overripe fruit are not good for human beings. So it is waste. Then below ripe, there are 2 more stages, that is unripe and underripe. These fruits are not yet ripe or not to be harvested. So they are of also no use. But I wanted to segregate these fruits once they come to the industry into 4 different categories and predict free fatty acid contents as well as the maturity level of these fruits. That was predicting free fatty acid contents was the major task. So what is done is this is the research problem definition. So in the first chapter, what I will be talking is I've implemented this using just a programming language. Then second, I went into research. I implemented this using fuzzy logic, then rough set theory, and then combination of fuzzy and rough set theory for achieving good quality oil. Why we are doing this? To reduce error which is done or introduced by human graders. So right now, the current practice of grading is human beings make use of sickles or chisel. They cut the branch, then the branch falls on the ground. And you have to remember one thing, that within 24 hours, you have to take those bunches in the industry and process. If you don't do that, then the fruits are of no use. You have to throw them out. So there was a need to automate the process so that we can reduce this processing time, taking the bunches from the farmers' place to the industry. And then, of course, after taking these fruits to the industry, they do some processing, randomly choosing some fruits and do some chemical analysis, find out whether the quality of oil extracted from this fruit will be good or no. So, of course, this is a manual process. So we wanted to do something which will be helpful for the for the farmer community as well as industry community. The objectives of this work was proposing framework for oil palm fruit grading using UML methodology. Now, why UML? Because suppose one more researcher comes and says that I want to implement this using so and so language, so my performance is better than yours. Of course, you can take my blueprint and do comparison, because this was the first research which I started in 2012. I wanted to give a blueprint to all the researchers. Yes, this is the basis. You can build your model on top of this and check whether my findings are better or your findings are better. Of course, I believe there is a scope for improvement. I cannot say my research is only best. Of course, your research is best. You go ahead. Then I implemented this using fuzzy logic, rough set theory, and combination of fuzzy rough and rough fuzzy set theory. And of course, comparison is done to check whether which method is efficient, taking into consideration time complexity and space complexity also. Now, these are just the methodology which we have used to achieve our objectives. First one is, you know, that UML methodology, you know that object-oriented methodology is used to design UML models, different models. Second one is soft computing techniques. That is fuzzy logic is a part of soft computing, and rough set theory is also a part of soft computing. When we talk about soft computing and hard computing, we know we have to understand one thing. Hard computing, what we achieve is 100% accuracy. For example, when we talk about flight, when flight takes off and lands, there should be 100% efficiency. You cannot say 99% efficiency or 98% efficiency, because we require 100% efficiency because we are playing with the lives of the people. But when we talk about soft computing, you cannot achieve, you can achieve, but 90% efficiency or 80% efficiency is acceptable. So these are the fuzzy logic and rough set theory are a part of soft computing. And then what we did is fuzzy logic, we wanted to improve the system of rough set theory also. So we tried to combine fuzzy logic and rough set theory and made a hybrid approach also for solving the same problem. It is grading of oil palm fruits. Again, I'll repeat what are the different grading stages. First one is ripe fruit, unripe fruit, overripe fruit, and underripe fruit. Now, this is the first chapter when I was talking about it. Just don't go into details. I will just tell you in this chapter, what we have done is we have collected the samples. Now, when I wanted to work on this topic, the biggest challenge what I faced is about the database. I wanted to train the system and test the system, but there was no data available. So I had to start from scratch, going into the farm, clicking pictures of good quality, getting them to the testing lab, then having some mechanism where we clicked so many pictures, around 3,000, 4,000 pictures, then rotating the fruit in different angles. Because we know that once from base to apex, when you talk about the fruit, the color changes, and we cannot rely on one image. So you have to turn the fruit in different angles, click the picture, check its check if the fruit is of different color or different shape. Everything you need to consider. Now, this is a basic block diagram of our research. What we did is we collected oil palm fruits, then given these fruits in front of the camera. Then we wrote one algorithm which will classify the fruits into 3 different categories. That is underripe, unripe, and ripe. And when the fruit falls in ripe category, what we do is we try to check the free fatty acid contents against some threshold value. If free fatty acid contents is less than or equal to threshold value, then it is of course ripe category. And if it is greater than threshold value, then it is overripe. This is the basic block diagram for grading of oil palm fruit. This is the algorithm what we proposed. As you can see, what we do is there are some initialization variables. Then we made use of different threshold values. Total, we have used 12 threshold values. And these threshold values are calculated rigorously by experimental. We went in the chemistry lab, we did some experiments. All the threshold values. So there are total 6 steps in our algorithm which are depicted here. And the threshold values which were calculated, as I've mentioned, are given in this table. So total 12 threshold values, and nomenclatures what we have used, that is X is nothing but row, Y is column, red, green, blue component we are trying to extract, and total number of red component, blue as well as green component. And we are using mean of green, blue and red component in this algorithm. Now, the biggest question is how to calculate threshold value. So to calculate threshold value, we have proposed this algorithm. What it does is, just for your kind information, just go in detail. We select an initial estimate, that is threshold. Then what we do is we divide that threshold into two groups of pixels, TH1 and TH2. Okay, and then we can compute the average gray level values of S1, S2 for the pixel in the regions TH1 and TH2. Then new threshold value, what we calculate is the S1 plus S2 divided by 2, and we repeat step number 2 to 4 until the difference in successive iteration is smaller than predefined parameter, that is TH0. Again, here there is a question of how to define the predefined parameter. Now, after interacting with the ICAR scientist, we came up with one threshold initial estimate, that is TH0, and we said yes, this is the initial estimate because this is all experiment we did in ICAR lab as well as one chemistry lab of Goa University also, and of course in Malaysian Palm Oil Board, because there was one researcher from Malaysian Palm Oil Board who is expert in all these things. Because we wanted to automate the things when we get a grants from any foreign organization, we have to be very specific and we have to make sure that our algorithm, what we are proposing, have to be good. Whether it is simple or complex, and that should be understandable, agreeable by both the scientists. Next, now when I spoke about UML methodology, this was the depicted algorithm which was proposed earlier. When we talk about unified modeling language, you know what are the advantages and why it is useful. So when I proposed this in one of the paper, I got very good citations in this paper because people mostly who wanted to do research, they were taking this as a reference and then trying to improve the system. Then after implementation, we got these results. In this graph, you can see there are three different colors. First one is red color, then green color, and blue. X-axis is nothing but fruit ID. As we know that I have taken more than 3,000 fruits, and Y-axis is for RGB values. You can see there are 4 different categories of fruit: unripe, underripe, ripe, and overripe. When fruit goes from ripe state to overripe state, you can see the red color component drastically increases. Also the green component, and blue component doesn't vary that much. So this was the observation made, and we wanted to find out that peak point when ripe becomes overripe. So when ripe becomes overripe, the fruit is waste. You have to throw it out, because the free fatty acid content is very high and that is harmful for human being if you consume it. So this was the analysis and study made. This is the graph of free fatty acid contents, which I just now mentioned. In ripe category, it is of acceptable range, but in overripe category, it is of unacceptable range. So you cannot take fruits which are of overripe category. So we wanted to segregate the fruits into 4 different bins. Suppose the fruit belongs to unripe category, automatically from the conveyor belt, it should go to unripe bin. And similarly, if the fruit belongs to ripe category, automatically from the conveyor belt, after camera processing, it should go to ripe bin. So there were 4 different bins and the processing should be done very fast. That was our motto. So we were trying to improve the system, how you can reduce the time complexity so the processing becomes faster. And these are the extracted observation table, extracted values from 4 different categories. As you can see in the last column, FFA content, the overripe category, it has FFA content more than 5. So if it is more than 5, which is unacceptable range, you cannot use that fruit for extracting oil. And you can see after taking more than 3,000 fruits, we extracted different values, and then we took their range from this value to this value. Then it falls in this category. So that was our basis for implementation. So this is the first chapter, which was the basis for our implementation. And then in the next chapter, you can see this is the implementation. When I was talking about the database or the samples collected, when you talk about all palm fruits, they look like this. Just go through the pictures. So what we have done is collected 50 samples from each category. One sample is rotated 20 degrees to check the change in the color in the same fruit. So like that, for one fruit, we get 18 pictures. And when we talk about 50 different samples, we get more than 3,000, that is 3,600 images. And what we did is we uploaded these images on the website, and now it is available for anyone. Whoever wants to do research in this area, they can download these images and make use of it. The clarity of these images are really very good. Those who are interested, they can play with these images. Now, when I talk something about free fatty acid contents, we as a computer engineer or IT engineer, we are not aware about what is FFA. Now, how to calculate this free fatty acid content? The procedure was given by ICAR Goa, and we followed the same procedure for 3,600 different fruits. It was very hectic and taxing for me, checking each and every fruit, extracting their, removing their mesocarp. What is mesocarp? Is nothing but the outer covering of the fruit. So remove that, peel it, then put it in some solution, wait for 8 to 10 hours, check the color. How we did titration in 11th, 12th when we went for science practical, chemistry practical, same procedure we followed. And these are the principles and reagents which are used. So there is a chemical procedure for the estimation of free fatty acid contents. So this is for your kind information. We don't have to go into detail. This procedure was designed by ICAR Goa. It's a standard procedure. We cannot change it. Okay. And what apparatus are used? What is the procedure? See, I was very new for this system, and then it took really long time for me to do all this work. But this was very important because we are trying to predict the free fatty acid content as well as the grading of fruits. So I wanted this to be very precise and get the correct results. So you should have a lot of patience to understand the system. This is what I was talking about. And how we calculated after getting results, how we calculated free fatty acid contents. These are the formulas used. These formulas are designed by ICAR. Okay. Now coming to conceptual view, we went to design phase now. We are ready to go to design phase. So you can see what we did is one casing where the fruit will come from the conveyor belt. There will be camera. Camera will do live processing, and then algorithm will be based on the desktop machine. So this was the experimental setup, conceptual view. Now, initially in the lab, what we did is this. This is the physical view experimental setup. You can see all the specifications of the lighting condition, as well as box dimensions, resolution of the camera. This was initially done for training the algorithm. Now, when we are testing, you can see the screenshot, what software we gave for Malaysian palm oil board. This fruit. Now, of course, what image processing role plays here is we background subtraction, then checking whether the image is clear or no, then making it, more crisper. Everything is done. Then you can see here the fruit category is unripe, and it extracts the red, green, blue value and also predicts the free fatty acid contents. So what we used to do is after getting these results, we used to save this in the database for our future analysis. This is the first category, that is the unripe category. You can see the color of the fruit. It is more of purplish black color. This is the second category, which is called as underripe category. This is the output, what we got. And you can see from the base to the apex, the color starts changing. You can see more of yellowish, reddish, orange color. This is the third category, ripe category. You can see the change in color in the fruit, and you can also see the free fatty acid contents. It goes on increasing. Here you can see it is more of orange, reddish orange color. And this is the fourth category. It is totally yellowish orange color. This category fruits are never used for extracting oil. And you can see the free fatty acid content is between 5% to 6%. So this software, what we did, it predicts the free fatty acid content, and also it grades the fruits. And of course, there is a provision to store the results in the database for future analysis. Now, results and discussion. After implementation, we want to analyze the system. As you can see, these 4 different categories, the color also changes. As the color changes, when you move from unripe to overripe stage, there is change in the figures, the values, what we get. So these are the mean values for different categories of fruits, which is very important in further analysis. Now, test result, you can see in the last column between manual and automated system. For first category, we got 100% accuracy. For the second category, that is underripe, we got 90% accuracy. For third category, it is ripe, we got 90% accuracy. And for overripe, of course, we got 100% accuracy. But our main concentration was on ripe category. When the fruit is ripe, it is very good for extracting oil. So we wanted to improve the system, 90% accuracy, very good. But can we achieve more accuracy? That was our main motive. So that's the reason we went. This is the conclusion, as I've already mentioned. So that's the reason we went to fuzzy logic. Why fuzzy logic? Everybody knows, because there is an uncertainty in color due to environmental condition. For example, when oil palm fruits are grown in eastern coast of India, the color of the fruit will be different because the environmental conditions are different. When you come to west coast of India, the color of the fruit may vary. We don't know due to the climatic condition. When you go to Indonesia, the color of the fruit varies. When you went to Malaysia, the color of the fruit varies because of the environmental conditions. So there is uncertainty. That's why we thought of going for fuzzy logic. So, and we know that in fuzzy logic, we have FIS editor, we do fuzzification, we do defuzzification. Then what is fuzzification? What is defuzzification? This I will not go into detail. You already know. So what we did in fuzzification is we used 4 linguistic variables for this. Of course, for our fuzzy FIS editor, there were 2 input variables and 2 output variables. So one of the input variable was color. And I've mentioned earlier, the color of the fruits belongs to these 4 categories, that is purplish, reddish purple, reddish orange, and dark orange. So these are the different linguistic variables, 2 input variables and 2 output variables, which are given for the export system which we design. And now this is just an example for you to understand what is fuzzy versus what is crisp set. When we talk about is the oil palm fruit ready for harvesting, it is crisp set, it will give you the answer 1 or 0. But when it is fuzzy set, it will tell you all 4 different categories with values 1, 0.75, 0.5, and 0.25. So these are some basics for our system. What we did is we divided the first input variable, that is the color of the fruit, into 4 different quadrants and given the value, because we know the membership function in fuzzy logic is between 0 to 1. So when it is 4 different, you can see linguistic variables, best solution is divide that 0 to 1 into 4 different parts. So you get 0 to 0.25, 0.25 to 0.5, 0.5 to 0.75, and from 0.75 to 1. So the first input variable, these were the basic rules used to define the framework description for fuzzy. These were the rules for the second input variable. You have to remember one thing. In the first method, we used only 1 input variable. Now this is fuzzy, we are using 2 input variables. The second input variable is the number of detached fruitlets. What is number of detached fruitlets is, currently the practice which is followed for grading of oil palm fruits is they check whether how many fruits are detached from the tree. They count the number of fruits from the bunches. Suppose the fruits fallen from the bunches are 0, then of course that category belongs to underripe. Okay, the fruits which are fallen from the tree are between 1 to 9, then it is underripe, not at reach for harvesting stage. And if the number of fruits are between 10 to 50, then the fruit is ripe. They make use of sickle, just cut the bunch, and that bunch falls on the ground. So within 24 hours, you have to take them to mill for extracting oil. And if the fruits are more than 50, then that fruit is overripe. So these were the two input variables. What we did is for our fuzzy logic inference system, we created different rules and then given for fuzzy inference system. And what output we get is two categories, that is a fresh fruit bunch category as well as free fatty acid contents. So these are the snapshots of the execution when what I spoke in the previous slides. Fuzzy set, this is the first number of detached fruitlets and the color. These are the two input variables and their membership functions. These are the two output variables and their membership function. I've used triangular membership function for this because it gives a promising results. Okay. Some of the rules which I mentioned here, the fuzzy set produces, what we have done is 16 different rules we have framed in order to classify the oil palm fruits in 4 different categories and predict their free fatty acid contents also. So these, you know that everybody, that this is FIS editor and these are the number of rules which we have framed, total 16 different rules. And this is the output, this is the tool viewer. For output, what we have done is we have made use of 5 different defuzzification methods, that is centroid, bisector, middle of maximum, smallest of maximum, and largest of maximum. And then we check which defuzzification method is suiting for our grading of oil palm fruits. These are some of the analysis. Okay, now what we found out is as the number of rules, as the number of input variable increases, the time it takes to process also increases in case of fuzzy logic. So we cannot waste more time in processing. Suppose we take 5 features of say oil palm fruits. It will have how many rules? It will have more than 25, 30 or 40 rules. So when you process all these rules in worst case scenario, it will take more time. So we wanted to reduce the time complexity, but at the same time increase the efficiency. So that's the reason we went to rough set theory. In rough set theory, we have a concept of, and we designed one algorithm also using rough set theory. This is the flowchart of the algorithm. What we do is we insert the data, check whether the validate the data. In rough set theory, you have to remember one thing. It also generate rules, but we go for redux. How we go for redux? Using upper approximation, lower approximation, and boundary region. So this is the detailed flowchart of our algorithm. We generate rule, but before generating the rule, we check for lower approximation, upper approximation, and boundary region using information table. And some mathematics, because when we talk about fuzzy logic, rough set theory, there is little bit of mathematics which is required. Discernibility relationship, indiscernible relationship, and so on. So then we have to find out also core and redux of the attributes. See here, this is for one category, we have to do this work in rough set theory. And this is for using 2 attributes, that is color and detached fruitlet. We are trying to find out the lower and upper approximation and boundary region also. So I'll just skip this part because it's more of research based. It will take more time for me. I will come to output. Now, if you see the output for one category, it is unripe category, you can see only 2 rules. Rule number 1 and rule number 2. But if you go to fuzzy logic, you have to scan all the 16 different rules for one category. So what we are trying to do in rough set theory is we are trying to eliminate the unnecessary redundant data and also improve the accuracy, reducing the time complexity. This is for different category. Second category, we have applied the same thing for second category, identifying reduced table and then indiscernible relationship. This is very, very important in rough set theory. But to be very frank, I was more comfortable in rough set theory than fuzzy logic, because if you like discrete mathematics, this is the best part of rough set theory. Okay. Then quality of approximation in rough set theory is very, very important. It will show you what is the probability of your rules which are correct, what is the probability of rules which are not correct, and what are the probability of rules which may or may not be correct. So from this, you can find out that green color, it shows 35% probability of our rules saying yes. Red color means probability of rules giving no answer, that is the 35%, 55% probability. And there is a confusion, suppose yes or no, 10%. So this is for unripe category, display of decision rules. Similar kind of analysis is done for other categories because it is very, very important to explore all the categories and define their rules in fuzzy logic also, so that our efficiency and accuracy also increases. So then what we found out in rough set theory is the number of rules, of course, have reduced. But are we trying to miss something in worst case scenario? After discussion with all the scientists, we came to know is yes, we might miss some rules in rough set theory. So what is the solution? Solution is to have a hybrid approach, combining rough set theory as well as fuzzy set. Okay, so what we did is hybrid approach is this data collection. Then the next step was finding the indiscernibility relationship, lower and upper approximation, and then applying fuzzy rules and getting the result. So after doing this, you can see comparison of different methods for one category. Using fuzzy logic and number of attributes 2, the total number of rules what we got for fuzzy logic is 4, for rough set theory it is 2, and when we combine, you get you get 3. And as the number of attributes increase, you can see the fuzzy logic rules increases, the rough set rules doesn't increase that much, because what we are trying to do is reduce the ambiguity in rough set theory, reduce the what you can say with the help of indiscernibility relationship, we try to find out approximation, that is upper and lower approximation. So eliminating unnecessary rules is done by rough set theory. So that's the reason we get 4 number of rules as the number of attributes increases. But when you combine rough set theory and fuzzy logic, you get number of rules at 7 for total number of rules. So as you can see, when the number of attributes increases, the number of rules also increases. When the number of rules increases, the system will take time in getting the results. So that is shown here in the form of a table, that is efficiency comparison. The first method what we did is for best, average and worst case, we were getting the same complexity, that is big O of m into n. This is, I'm talking about a time complexity. For fuzzy logic, for best case, we were getting big O of 1. And for worst case, we were getting big O of n, because when all the rules, for worst case, we have to implement all the rules, we have to run all the rules. And for rough set theory, what time complexity what we were getting is big log of n, which is better than the fuzzy logic. Then what we thought of combining both fuzzy logic and rough set theory. So we got very good results for the hybrid approach. So this is the research which we did today, and I'm continuing that research as a part of my further studies. These are some of the references which I have used for my research. And yeah, I'm done. So if there are any questions, please feel free to ask. Hello?
Yes, sir, we are here. Yes. Yeah. Dear participants, do we have any queries?
Yeah, participants, if you have any doubts, you can unmute yourself.
I think I know it's very they must be attending the full session for past 1 week, so no problem. I will tell you now. Actually, for the medal which I got for my current research, that is postdoc, is what I'm trying to do is I'm trying to predict the wine quality of homemade wine. Okay, this is something innovative topic which is not done. You can check. Already I have one paper is published and I'm still working on it, wine quality prediction. So my research is related to applications of computer engineering in agriculture. So if you have any questions, please feel free. My next research will be on amaranthus tricolor. I'm trying to apply some data analytics algorithm for the for my research, which I'm doing for postdoc. So if you have any questions, please feel free. At the same time, my research for DRDO, I got a grants from DRDO. That was something different. That is natural language processing. And of course, it was the really fantastic project which we did for DRDO New Delhi. So I'm trying to actually learn. I'm not confident, but I'm trying to learn these things, new things. We know that in computer engineering, everything every day changes. Now, yesterday it was blockchain, then big data analytics. Now it is something else. So we have to keep ourselves updated. So if you have any questions, please feel free.
Yes, sir. I hope they are clear about the topic.
Okay, fine.
So, participants, if at all you have any questions, you can type in the chat box also, or it's in the WhatsApp group, so that we will take it from there. Okay, sir. I hope they are much more clear about the topics, and you already mentioned your postdoctorate topic also, and you thanks for your open hands for doing some research on that the quality of the wine, which was homemade quality of the wine, and which was new topic. Thank you so much.